Look around you. The chair you're sitting in, the screen you're reading this on, the roof over your head. Somebody, somewhere, had to figure out how to make it. They had to get their hands dirty. They had to solve problems you and I don't even think about. But what happens when that impulse to build, to create, to solve a problem gets scaled up? I'm not talking about building a better mousetrap. I'm talking about moving mountains, building cities from scratch, and taming rivers that could swallow a town whole. This is where engineering stops being just a job and starts looking a lot like a superpower. It's the story of human ambition written in concrete, steel, and sheer, unadulterated grit. We're talking about projects so massive they can be seen from space. Projects that take decades to complete and cost billions, sometimes trillions of dollars. It's easy to get lost in the numbers, the mind-boggling statistics of tons of concrete and miles of cable. But behind every one of these behemoth projects is a human story. It's a story of struggle, of trial and error, of sleepless nights and back-breaking days. These are the places where things go wrong, where unexpected challenges pop up and threaten to derail the whole operation. So, let's take a trip around the globe. We're going to look at some of the most ambitious, most audacious, and downright unbelievable engineering projects happening right now as you read this. These aren't just buildings or bridges, they are monuments to human ingenuity. Let's get our boots on. Down in Australia, they're tackling a huge energy problem. You see, the sun shines a lot and the wind blows hard, which is great for solar and wind power. But what happens when the sun goes down or the wind stops? The lights go out. That's the problem. Their solution is something called Snowy 2.0, and it's basically the world's biggest, most ambitious battery. But it doesn't use lithium or acid, it uses something much heavier water. And to make it work, they have to go deep underground, carving out caverns and tunnels through solid rock in the middle of the snowy mountains. Here's the simple version of how it works. They are connecting two existing dams, Tantangara and Talbingo, with about 17 miles of tunnels. When there's a surplus of cheap renewable energy, they'll use it to pump water from the lower dam up to the higher one. Then, when the city of Sydney needs power during peak hours, they let that water rush back down through the same tunnels, spinning massive turbines along the way and generating electricity on demand. The challenges are, as you might expect, enormous. We're talking about giant tunnel boring machines, or TBMs, grinding their way through miles of unforgiving mountain rock. The workers operating these things are deep beneath the earth, dealing with immense pressure, groundwater, and geology that can change without warning. So what's the big deal? Well, when it's finished, Snowy 2.0 will be able to store enough energy to power 3 million homes for an entire week. It's a game changer for Australia's power grid, making renewable energy reliable 24/7. If you think your local airport is big, you need to see what they've built in Beijing. It's called Daxing International Airport, and it's not just an airport, it's an aviation metropolis. From the air, it looks like a giant golden starfish spreading out across the landscape. This thing is designed to handle an insane number of people. We're talking about an initial capacity of 72 million passengers a year, but it's built to eventually handle over 100 million. That's more than the entire population of most countries passing through one building. The scale is almost comical. The terminal building alone covers 7.5 million square feet. You could fit 97 football fields inside it. The purpose is simple. Beijing was bursting at the seams. The old airport couldn't handle the traffic, leading to massive delays and congestion. But building something this big, this fast, is a monumental task. The project went from the first shovel in the ground to the first flight taking off in less than 5 years. That's an absolutely blistering pace for a project of this complexity. It required a massive, coordinated effort, with tens of thousands of workers on site day and night. One of the biggest engineering challenges wasn't just the size, but the design. How do you make a terminal that big user-friendly? Nobody wants to walk 2 miles to get to their gate. The architects came up with the starfish design for a reason. All the gates are located in the legs of the starfish, and at the center is a massive, open hub. This clever layout means that the farthest gate is less than a 2,000-foot walk from the central security checkpoint. They also built an entire transportation network underneath it, with high-speed trains, subways, and expressways, all converging directly below the terminal. Here's a fact that gets me: the roof is covered with over 8,000 unique window panes to let in natural light, and the whole structure was designed to withstand major earthquakes. But the truly amazing part is what it represents. This isn't just about moving people from point A to point B, it's a statement. It's a country showing the world its engineering prowess, its organizational might, and its ambition for the future. For centuries, if you wanted to get from Germany to Denmark, you had two choices: a long, roundabout drive or a 45-minute ferry ride across a stretch of the Baltic Sea called the Fehmarnbelt. The ferry is fine, but it's slow, and weather can shut it down. So engineers from both countries put their heads together and came up with a ridiculously ambitious plan. They decided to build a tunnel. Not just any tunnel, but the world's longest immersed tube tunnel. It's an 11-mile-long underwater highway and railway that will sit on the seabed, connecting the two nations directly. The Fehmarnbelt fixed link will cut travel time from 45 minutes by ferry to just 7 minutes by train or 10 minutes by car. This is a huge deal for trade, for tourism, and for simply connecting the people of Scandinavia with mainland Europe. You can't just dig under the sea, the geology isn't right. So they're building it in pieces. On land, they are constructing massive hollow concrete tunnel sections. Each section is about 700 feet long, 140 feet wide, and weighs a staggering 73,000 tons. Once a section is built, they seal both ends, float it out into the sea, and then carefully sink it into a pre-dredged trench on the seafloor. They connect it to the previous section, pump out the water, and repeat the process 89 times. It's like building with the world's biggest, heaviest Lego bricks, all while battling ocean currents, weather, and the immense pressure of the water. The most mind-blowing part of this whole thing is the precision required. These colossal sections have to be placed with pinpoint accuracy at the bottom of the sea. The entire project is a masterpiece of logistics, marine engineering, and sheer brute force construction. When it's done, you'll be driving or riding a train through a concrete box on the bottom of the ocean and probably won't even realize it. It's a hidden mega project, an invisible monument to human cooperation and our relentless desire to shorten the distance between us. In the highlands of Ethiopia, a project is underway that could change the destiny of a nation and a continent. It's the Grand Ethiopian Renaissance Dam, or GERD, and honestly, it is one of the largest and most controversial dams in the world. For decades, Ethiopia has watched the Blue Nile River, the source of over 85% of the Nile's water, flow right through its territory and out to its neighbors Sudan and Egypt, without being able to use it for power. The GERD is Ethiopia's effort to change that, to harness the incredible power of the river to generate electricity for its more than 120 million people. The purpose is crystal clear power. A huge portion of Ethiopia's population lives without access to reliable electricity. This dam is designed to solve that problem in a big way. Once fully operational, its turbines will generate over 6,000 megawatts of electricity, more than doubling the country's current output. This isn't just about keeping the lights on, it's about powering schools, hospitals, and industries. It's about lifting millions of people out of poverty and, kickstarting a new era of economic development. For Ethiopia, this dam is a symbol of national pride, sovereignty, and hope for a brighter future. However, you can't just put a cork in the world's most famous river without creating some challenges. The primary one is geopolitical. Egypt, which lies downstream, is almost entirely dependent on the Nile's water for its survival, and has been for thousands of years. They are deeply concerned that the filling and operation of the dam will drastically reduce their water supply, threatening their agriculture and way of life. This has led to years of tense negotiations between Ethiopia, Sudan, and Egypt. The engineering is one thing, the diplomacy is a whole other beast. It's a high-stakes balancing act between one nation's right to develop and another's right to exist. The stats on the dam itself are impressive. The main structure is over a mile long and 500 feet high. It required over 10 million cubic meters of roller-compacted concrete to build. But maybe the most surprising detail is that Ethiopia is largely funding this colossal project itself, through government bonds and public donations. It's a testament to the collective will of a people. The GERD is more than concrete and turbines, it's a powerful statement about self-reliance. High in the bone-dry Atacama Desert of Chile, on top of a mountain called Cerro Armazones, astronomers and engineers are building a new eye to look at the universe. And when I say eye, I mean it. This is the Extremely Large Telescope, or ELT. The name isn't very creative, but it is accurate. This thing is a monster. Its main mirror will be 39 meters, that's 128 feet, across. To put that in perspective, it's wider than a basketball court. This single mirror will collect more light than all the other major research telescopes in the world, combined. The purpose of the ELT is to help us answer some of the biggest questions we have. Are we alone in the universe? How did the first galaxies form? What is dark matter and dark energy? This telescope will be so powerful it will be able to take direct images of planets orbiting other stars, and even analyze their atmospheres for signs of life. It will be like upgrading from a pair of binoculars to the Hubble Space Telescope and then some. It's a tool designed to spark a revolution in our understanding of the cosmos, pushing the boundaries of what we know. Of course, building the world's biggest and most advanced telescope on a remote mountaintop isn't exactly a walk in the park. The main mirror is too big to be made from a single piece of glass. Instead, it's composed of 798 individual hexagonal segments, each about 4.5 feet across. All of these nearly 800 mirrors have to be perfectly shaped and then controlled by a complex system of computer-guided pistons that adjust their position hundreds of times per second to form a single, flawless, reflective surface. This adaptive optics system is what will allow the telescope to correct for the blur caused by Earth's atmosphere, giving it images sharper than what we can get from space. The most incredible part of this project is what it represents for human curiosity. We are spending billions of dollars and dedicating millions of man-hours to build a machine whose only purpose is to look up and wonder. The dome that will house the telescope is a massive engineering feat in itself, standing nearly as tall as the Colosseum in Rome, designed to protect the delicate instrument from the harsh desert environment. The ELT is a testament to our innate drive to explore, to understand our place in the universe. It's a mega project dedicated not to power or transport but to pure knowledge. Imagine building a brand new city from scratch. Not just a new neighborhood, but an entire city, for nearly 1 million people, on land that didn't even exist a few years ago. That's the vision behind Forest City, a massive and controversial project in Malaysia, just a stone's throw from Singapore. The project is being built on 4 man-made islands reclaimed from the sea in the Johor Strait. We're talking about creating 5,000 acres of new land out of sand and rock. It's one of the most ambitious urban development projects anywhere on the planet. The idea behind Forest City is to create a smart and green futuristic metropolis. The plans are straight out of science fiction. The city is designed to have a layered structure, with roads and parking hidden underground, leaving the surface level completely dedicated to pedestrians, parks, and green spaces. The buildings themselves are meant to be covered in vertical gardens, creating a literal forest city where architecture and nature are fused together. The goal is to create a high-tech, eco-friendly city that could serve as a model for future urban living, attracting businesses and residents from all over the world. As you can guess, the challenges are off the charts. First, there's the monumental task of land reclamation. You have to dredge millions of tons of sand from the seabed and deposit it to create stable new islands, a process that has raised significant environmental concerns about its impact on marine ecosystems. Then, you have to build all the infrastructure, power plants, water treatment facilities, roads, bridges, and housing, on this brand new land. And on top of all that, the project has faced economic and political headwinds, with questions about its financial viability and who will actually live in this futuristic city. The surprising thing about Forest City is the sheer audacity of the vision. It's not just an expansion, it's an attempt to create a utopia. While the project has slowed and faced criticism, the core idea remains fascinating. What if we could start over? What if we could design a city from the ground up to be more efficient, more livable, and more integrated with nature? Forest City is a real-world experiment in answering that question. For the Dutch, fighting against water is a national pastime. A huge chunk of the Netherlands is below sea level, protected by a complex system of dikes, dams, and seawalls that have been built up over centuries. But with climate change causing sea levels to rise and rivers to swell more frequently, the old approach of building higher and stronger walls isn't enough anymore. So, they came up with a radical new idea. Instead of fighting the water, why not make room for it? This is the philosophy behind the Room for the River program, a nationwide mega-project that has transformed the Dutch landscape. The purpose of this project is flood protection, pure and simple, but it's a total rethink of how to achieve it. Instead of just raising dikes along the major rivers like the Rhine and the Meuse, the Dutch have strategically lowered floodplains, moved dikes inland, created new side channels, and even temporarily deepened riverbeds. In over 30 locations across the country, they have fundamentally redesigned their river landscapes to give the water more space to spread out safely during peak flows. In places like the city of Nijmegen, they actually dug a whole new channel for the Waal River, creating a new island in the middle of the city and effectively doubling the river's capacity at that bottleneck. This involved moving homes, building new bridges, and completely reshaping the waterfront. Each of the 30-plus projects had its own unique challenges, requiring a combination of civil engineering, landscape architecture, and a whole lot of community consultation. You can't just tell people you're moving a dike into their backyard without a good conversation. What's truly inspiring about this project is the shift in mindset it represents. For 1,000 years, the Dutch motto was, "God created the earth, but the Dutch created the Netherlands." It was a story of conquest over nature. The Room for the River project is a story of partnership with nature. It's an admission that sometimes the smartest engineering solution is to work with natural forces instead of against them. It's a forward-thinking, adaptive approach to climate change that other low-lying regions around the world are now studying closely. It proves that sometimes, the biggest, boldest move you can make is to take a step back and give nature some breathing room. So, we've tunneled through mountains, built cities on the sea, and aimed a giant eye at the stars. What does it all tell us? To me, it says that the human spirit of invention, that desire to build, to solve, to reach for something just beyond our grasp is alive and well. These projects are more than just concrete and steel. They are the physical manifestation of our collective ambition. They are stories of thousands of people getting up every day, putting on their hard hats and steel-toed boots, and chipping away at a problem so large it's almost impossible to see the end. Each of these mega projects in its own way is a gamble on the future. We're building dams to power cities that don't yet exist. We're building tunnels to connect economies for the next century. We're building telescopes to answer questions we haven't even thought to ask yet. It's an act of faith. It's a belief that the future will require more energy, faster connections, and a deeper understanding of our world and our universe. These projects are the foundations we're laying down today for the generations that will come after us. Of course, it's not all sunshine and rainbows. These projects are incredibly expensive, they can have huge environmental impacts, and they can displace communities. They force us to ask hard questions about what we value and what price we're willing to pay for progress. The story of engineering isn't just about success, it's also about learning from mistakes and understanding the consequences of our own incredible power to reshape the planet. The conversation around these projects is just as important as the construction itself. It's where we figure out what kind of future we actually want to build. But at the end of the day, I can't help but feel a sense of awe. In a world that can often feel divided and stuck, these projects are proof that we can still do big things together. They show that when we unite behind a common goal, whether it's national pride, scientific discovery, or simple survival, our ability to achieve it is nearly limitless. It's a reminder that our greatest tool isn't a crane or a computer, but our capacity for cooperation and our relentless